4.1. We're here. Some of this, some of that. Yeah, look at that. The charcuterie board.
I like the honey spoon thing.
Yeah,
I've always wanted one of those.
it's nice. Okay, first thing that we're going to do is we are talking about a new type of function. Okay. What you are going to do first is to connect the context in the graph by creating a story that matches this graph. You can name the axes whatever you'd like to. Typically, like the bottom axis is something like time, but it could be distance and it could be altitude, something like that. So you can go ahead and try to create a story for this function.
What? No.
Yeah.
How long do we have?
Flashbacks.
Wait, real quick. How long do we have to write?
About 4 or 5 minutes. Okay, so don't be talking about flashbacks right now. If you have a question, you may ask me. But other than that, we should not be chatting. Very good. I gave you guys your final study guides, right?
No. For biology, yes.
For
but-
biology,
yeah.
Oh, I meant to do that on Friday. It's fine. Here they are. Sure.
Oh, did you take noise?
We got Scrooge in the house.
Scrooge is in the house. Boo, 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 boo.
Mine is energy drinks because why not?
Excellent.
Do you like the story? It's my story. I'm gonna tell you just one energy drink within a minute. With well, one minute, but like. Oh, I'm back as they go. I can see the walls in the door.
That's actually how we get to Narnia.
I wanna go.
I'm the only one allowed.
The math class goes on a trip to Narnia. Mr. Crosby walks in.
Yeah,
Where are they? In my band room, you have a
Okay, someone tell me a story. Tell me the story.
So Carl drinks 5 energy drinks in an hour's period of time. Yes, Carl.
Carl.
By 2 hours, he hasn't drank anymore.
Cracking. We should have left that.
By the third hour, he's drank 15 energy drinks.
It's not
Where's your
healthy.
teacher book?
It's
It's fine.
What do you mean?
Do you not
Because
have a
that's-
teacher book for this? With all the answers?
Why
in it?
is
Oh,
think
it's
about
weird.
how much energy right now.
I do.
Dead.
Okay.
I'll just turn this in. I wanted to check
Carl
this
is
last
a-
one because when I looked it up, I didn't understand it.
Gotcha.
But
It's Carl.
Okay. Sorry, tell me about Carl. Carl.
So he. This is Carl from Jimmy Neutron, by the way.
Yes.
That's why.
Great.
So
Okay, so what about him?
he was able to drink 5 energy drinks within 1 hour.
Okay.
And then by the second hour, he hadn't drank any more.
Okay.
Then by the third hour, he had drank 15 in total, so 10 more energy drinks.
Okay.
The door open.
And when it got to the 4th hour, he was running out of energy drinks.
He was. Okay.
And there you go.
All right.
Mine probably wouldn't work.
Mine just was like energy.
Interesting. Okay. Yeah. Share yours with us, dude.
Oh yeah, we got Bob.
Bob and Carl, sick. Okay.
It's climbing a mountain.
Okay.
It starts off pretty steep, then it's flat. After a while, it gets really steep, and he reaches the top of the mountain. After that, it decelerates and he goes down.
Okay. Cool. So what is your x-axis there?
X-axis is that like the altitude, not the altitude, the
Y-axis, I think, is your altitude, right? What would your x-axis be?
would be time.
Time. Okay. So sounds good. Cool. That works.
I don't know. I didn't really think about that.
Okay, so the x-axis could be time. It could also be distance. Like if you wanted to say like
yeah.
he traveled, 5. Well, it would be kind of crazy because that would be really, really a steep hill. But it's possible. He might be rock climbing.
Anything's possible.
Anything is possible. Okay, yeah, good. Any other stories you guys want to share? Yes, Hadassah.
It's gonna be something like this. So, it starts with Nate is running up a hill. Man, I
A
just
heel?
said it like my brother's
He's running-
heel.
It is
Is he
habit
small?
now.
He says
He
heel.
says heel.
Okay, so he's
Heel.
running up the heel.
Have you guys shrunk the kids?
And then he reaches a point where it's flat, so he is walking. And then he reaches a really steep incline and goes up it at a relatively fast pace before running back down.
Okay, sounds good.
And then I think y-axis would be speed and the x-axis would be distance, but I don't know if that would work. I've been switching them around a lot and I just can't remember how to do it.
So speed, if it was speed, that means that like
Maybe altitude.
altitude might work a little bit better because speed, that would mean that he's like increasing in speed for the first 5. Then his speed stays the same and then he increases again.
And you could have him slowing down like the race.
Yeah, so it could be like that. Although when you finish the race, you gotta speed up. So you hit the finish line and then you slow down.
You're on track. You just kind of go through, and then once you hit that end, you're just. You
No.
just kind of have to either run into a fence or just fall.
Oh.
It's fun. I choose the fall method because there's usually grass.
You just
Okay, if you were to write a function for each part of that story that you created or section of the graph, how many functions would you write? 4, right? There is the point from 0 to 5,
yeah.
then from 5 to 10, 10 to 15, 15 to 20, right? Yeah, good. So let's go ahead and write those functions. The functions go on the left side. The domains will need to go on the right side. So what I just talked through real quick was that's the domain. So let's do those domains first. What are the domains that we just kind of talked through?
The domains are the domains are
Is domain Y or X?
oh, that's what we're talking about.
It's X.
It's X. Yeah. So what's the first portion of the graph?
5,
It goes to 5. Where does it start?
0.
0, right? So our first domain will be 0 is less than or equal to X is less than or equal to 5. What about the second part? Yeah?
10.
Yeah, it goes, where does it start?
5. It starts at 5, and then it'd be is less than or equal to x, and then less than or equal to 10.
Good. And what I'm actually going to do is, since we were equal to 5 up here, I'm going to just say less than 5 here, or is greater than 5. 5 is less than x, sorry. Rather than less than or equal to there. Then the next section. Say again. Yeah, and where does it start? Yeah, it goes 10 to 15, right? So 10 is less than x is less than or equal to 15. And again, I use just the less than here because I use the equal to over there. And finally, what's the last one? Yeah, Jacob.
15 is less than x, which is less than or equal to 20.
Very nicely done. Good. Okay, so now I have this separate. I have this. Gosh, I'm a snake. I'm a snake. Okay, anyway, now I have this separated into its different parts, right? Via the domain. Now I have to determine what the function is for each of those. Now these are these, what kind of functions are they? Yeah, they're all linear, right? They're all just straight lines. So that means that I can use the form of y equals mx plus b. What does m stand for again? Slope. Good. So m is the slope. How can I calculate for slope?
Rise over run.
Good. It's rise over run. If I just have two numerical values, how would I calculate? Or 2 points, how would I calculate it? Do you remember?
You subtract the y-intercept.
Yeah, you subtract the y points. So we usually say y2 minus y1.
Over x2 minus x1.
Yeah, very good. So that's how I can calculate for the slope. Now, if I can't see, because b is what?
B is the y.
Y.
Good. If I can't see the y-intercept, how can I find the y-intercept? How can I solve for the y-intercept?
Plug into a point and solve for b.
Yeah, very good. So solve by plugging in a point. For x and y. And solve for b. Very well said. Okay. So this first one, I do see. Sorry, I'll let you guys finish writing that.
This is the one type of math I like, which is graphing. So it's like,
It's W.
The only math that I liked in 8th grade was you would draw lines or whatever, and then you would like color.
Oh, nice. So like less than or equal to those ones,
Yeah,
or
something like that.
okay,
But
cool.
like,
look at Mr. Wolf.
I didn't really understand it that much, but it was really fun coloring it.
Nice.
I like your hat.
Thank you. So this first one, we see the y-intercept, right? Where's the y-intercept for this first one?
0.
0, right? So that means that our plus b will be plus 0 in this case. What about our slope?
We can solve it.
You could solve it.
Or
This
it's
one's,
different.
It's easy though.
you can solve it, but this one, when we look at it,
Over one.
you can just analyze and see that it goes up 1 over 1. So the slope is going to be 1 over 1, or just 1.
Yeah.
There's only one left.
But you can solve it as well. So anyway, here is the 1 over 1 x plus 0. Do I have to write the 1 over 1?
No, just write 1.
Do I even have to write 1? I could just write x,
Oh, you can.
because there's an implied 1 there, right? What about the plus 0? Do I need to write plus 0? No, I don't, because plus 0 doesn't change the value. So I don't have to write it. Right? Because there are a lot of things like,
It's just weird though. Like if you just gave me x, I wouldn't just say,
understand.
oh, that's the something that's like we're looking at a line here.
but we do want to recognize that, because look at what's happening right here. This is actually saying f of x is equal to x, right? So it is actually stating a function. But there are all sorts of implied things, right? There is 1 over 1 out front of this. You could say it's over 1. You could say it's raised to the first power. You could say it's adding 0 to it. All of that is implied in x, right? So all of this is what we understand is true about x, but we don't have to write it all the time because it doesn't. None of that changes x's value. Those are all called identities when it doesn't change the value of something. So like multiplying something by 1 is called a multiplicative identity. Dividing something by 1 is called a dividing identity. Divisive? I'm not actually sure, but it's the identity. And adding by 0 is the additive identity. You could also say minus 0 because it doesn't change the value, right?
I didn't realize that there was another page with the actual function on it, so I was like,
Oh no,
so I just wrote it over here first, and I was like, oh,
that it is.
it's good though.
Good. All right, the second part. What is the second part? What's the function for that?
Wouldn't it just be like,
What would the slope be of this one?
0? There wouldn't be a slope.
Yeah, we have no rise. We have run, but if it's rise is 0 over a run of 5, that's just 0, right? So when we're writing our function of y equals slope m x, what is going to be 0 times x?
0.
It's going to be 0, right? It does change the value. So I don't even need to write that. And then y equals 5, because if I were to look at this extending out here, it would cross at the y-intercept of 5. So it'll be plus 5. So because that's 0x, I'm just going to say 5. Now what about the third function?
We have a slope.
We do have a slope. What is it?
It is.
Jacob, tell us.
It's up 2 over 1.
Yeah, it's up 2 over 1. So see how there are 2 vertical jumps and then 1 horizontal jump? So it's 2 over 1, or what's 2 divided by 1?
2.
Just 2, right? So my m is 2. Now I have y equals 2x plus b, and I cannot see where this one crosses the y-intercept, right? So how can I figure out what b is?
We can plug in a point.
Yeah, I can plug in a point. What point do you guys want to use?
Let's do. We can just do 10, 5.
Yeah, let's do 10, 5. So I'm going to plug in the point 10, comma 5, where this 5 is the y, 10 is the x. So I've got 5 equals 2 times 10 plus b. What's 2 times 10?
20.
Good. And then how do I get b by itself?
Subtract 20.
Very good. 5 minus 20 is what?
Is that?
Negative 15.
Very good. So negative 15 equals b. So then I'll go ahead and put that back up in here. And I get y equals 2x minus 15. So I'll plug that in now. Ooh, now that looks more like an equation that we're used to seeing.
Yeah. So go.
So this is plus, but the y-intercept is negative, right? That upwards happens with the slope, the positive 2. Good question. And now, what's our slope for this last one?
Down 1 over 1.
Yeah, so it's down 1 over 1. So we've got a negative 1 over 1. So how would I write that?
Negative 1x. Or just negative x.
Yeah, so negative 1x or just negative 1, just negative x. Now, can I see where this one crosses the y-axis?
No.
I can't see this one either, so let's pick a point to plug in and solve for b. What point do you guys want to use?
15.
Sweet, let's do 15, 15. What?
It's the only one that we could really use.
Well, we could use any of these points. We could use 16, 14,
Yeah, but that, I meant not
Choose.
you can see.
17, 13. That's true. 18, 12. We could use any one of those points. 19, 11. And just for good measure, we could use 20, 10 if we wanted to. any of those points through which that line passes, we should be able to use. But let's use 15, 15. How do I get b by itself?
Subtract 15. Add 15.
Good correction. What's 15 plus 15?
30.
Mm-hmm. So now I get y equals negative x plus 30, because I just plugged that back in there for b. So negative x plus 30.
Does this count as annoying?
Does this count as annoying?
Yes.
Okay, so now let's talk about what are some connections between the functions that we wrote over here and our stories that we wrote. Context, yeah, I want you to connect that to each of your own functions. I'm gonna go grab some more coffee.
I don't know.
Yeah, my story made no sense now that I think about it. So it's like,
Yeah.
it's like, how do I connect these? That's what I think.
Oh,
about
you
the
want to know
recording.
why I
So,
chose Nate?
Nate. Is it because hockey? Wow.
Yeah, because I call Nathan and Nate at this. I call them all so many different names. I call Miko the Moose. I call him Miko. I call him Ranton, and I call him Ranton. And sounds like a car rep.
Banana.
I call him 96.
It's a banana.
Five
Next
different
to a
names for
banana.
one player. One player has 5 different nicknames that I use.
I did Carl because Carl Jacobs, but I had to say drink because I couldn't.
All I can
Because
think
I-
of
The
was
other
Bob.
Because I can't do the other one.
Bob's a what?
Yeah.
King Bob.
Get rid of this. Like, stop. Land. You two little captain. I can't. This is
I
all
don't know how to connect our story because now that
I don't
after this
just
process,
doesn't
it
make
don't
sense.
connect.
So do we maybe need to revise our stories then?
Yes.
Okay, do that. And then make connections. Also, you know that this is recording everything you're
Yeah.
saying, right?
Okay.
I was like, it's recording. So.
Yeah, it's fine.
You're just gonna hear me going ba-da-da, next to a ba-da-da-da.
Okay, so how are your stories coming? Is my question.
How does a function connect to a story?
If I were telling a story, let's say, here's maybe how I would tell a story. I would say maybe that the y-axis is altitude and the x-axis is time. Okay? So if I were telling a story, maybe what I would say is like, at that point at which I have a slope of 1, I'm on a ski lift. And I got on a ski lift and I, for about 5 minutes, am just going up the hill, right? But then I want to actually get all the way to the top of a mountain. So I have to get on another ski lift. So like, let's say I'm at Pebble and I get on the ski lift at Aspen. So that shorter ski lift at the bottom, that gets me to right about here. But then I want to go all the way to the top of the mountain. So I can't just go straight to the top of the mountain because I have to get to the other ski lift, right? So I go over to the other ski lift where I'm not increasing my altitude at all. I just go over to the other ski lift and I have to wait in line. So it takes about 5 more minutes. And then I get on, and that ski lift is faster than the ski lift at Aspen. So that ski lift takes me more quickly all the way to the top of the hill. It definitely takes longer than 5 minutes, but just for the context of the story, it takes me about 5 more minutes to get to the top of the hill. And then I start skiing down the hill at a nice leisurely pace that was actually a little bit slower than the ski lift for 5 more minutes. And then I had to stop recording because after this I bombed the rest of the hill and just went as fast as I could. So that's how I would connect that story, okay?
Yeah,
Something like that.
It's the edge of the page and it just goes.
I finally.
Slow down.
Okay,
I changed my.
so I want you to kind of come up with that function there quickly. Go ahead and say more about it. Oh, that coffee is so bad. I want more green coffee.
This is why you go and get your own. You gotta get it home.
I did make it at home, but
Though to be fair, it doesn't take you like 5
That's why we
hours
smell
to
that
drink a
water.
cup of coffee. So
Whoa, we changed that quickly.
all right.
It went from energy drinks to a runner.
So now this function is created in several pieces, right? How many pieces did we say it has? 4, right? So it has 4 pieces. We actually call this function a piecewise function because it's made of several pieces. Okay, so that's just what we've given it for a name. It's called a piecewise function. Now, the formal definition in mathematics is that a piecewise function is a function defined by more than one subfunction. Okay, so it has more than one piece to it. Each section exists also only in a certain interval, right? So I don't have this line being extended all the way down here forever, right? It stops right here. It has a starting point and a stopping point. So if I were to graph all of these lines, like let's say in Desmos, right here, I have the function y equals x, and then I also have the function y equals 5, and then I have the function y equals 2x minus 15, and then I have the function y equals negative x plus 30.
They always just keep going. They don't.
They all overlap, right? It's like chaos. Okay? But when I constrict their domains, then I see that this function actually tells a story of here to here to here and back down to, well, it ends right there, right?
At the point of intersection is when you would. 'Cause like.
Yeah, so in this case, I pick a point of intersection, and that's where I constrict the domains. I say this function only has its domain, the red function only has its domain from 0 to 5. And then the blue function only has its domain from 5 to 10. And so I constrict those domains, and that way, rather than having all of these functions that overlap and wouldn't actually create a function, now I can create one single function out of all of these functions. Okay? So that's what we're doing in a piecewise function. We are taking several pieces, which all of their functions look like this whole thing. It's a whole smorgasbord. But then I take all those functions and I create one function out of them by constricting their domains. Okay? So now we're going to look back at that function and we're going to try to analyze it for a couple of things. So for example, what would f of 12 be? If x is 12, what is our output? What is the function equal to? So I come back up here, and where is 12 on the x-axis? 2 past 10. Yeah, there we go. So it would be right here, right? So where does that hit the function then? What is the function equal to at f of 12?
9, 12, or 12, 9, I suppose I would put it.
Yeah, it's right up here, right? So I could say that that is 12 comma 9. So f of 12 is equal to 9. I just want to use my function for a quick example, the story that I told. What would this mean in the context of that story?
Would it be like
Oh no, it wouldn't. No, it's not
the
because of that.
point on the like ski lift at which you're at a certain time, which would be 9?
Yeah, so
does
the-
that make sense?
Yeah, so the altitude would be 9 for 12, like mine is kind of like minutes, right? So my altitude would be 9, and that might actually be like 100 feet or something like that, depending on what my y-axis is. I might say hundreds of feet, so my altitude is 900 feet, after 12 minutes of having been on these lifts and then waiting in line. Right, so that's my altitude at minute 12. Okay? Now, we looked at this graph to figure out where 12 was, but how do you think I could figure it out if I was just given this function right here? How could I find out what the output is if x is equal to 12?
Would you plug it into the function for whatever the closest domain is?
Yeah, so I have to look at the domain and say, okay, does 12 fit here? So, like for this first one, is 12 between 0 and 5? No, so I can't use that first function. Is 12 between 0 or 5 and 10? No, 12 is not between 5 and 10, right? Is 12 so it's not that function. Is 12 between 10 and 15?
Yes.
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 So
So
then you
because
plug
12
that
is
in as
between
your
10 and
x.
15, I can use this function.
2 times 12, which is 24, minus 15 is, that's a good question.
At least you didn't go 7.
7. It's 9. Wow,
Whoa.
that's like the number. Wow.
Yeah. So whether we use the function, this piecewise function that we've written, or we use the graph, it should give us the same value, right? Okay, the next one. Oh, that was number 6. Which subfunction would we use? We would use the third one. Right? So now, find the following. What is f of 7? If I were to come up here, where is x equal to 7? 2 more than 5, right? So what's our function at 7?
7, 5.
Yeah, the y value is just 5. So you could say at f of 7, it equals 5. But I also want to look up at this function and say, how could we do that algebraically?
5 is less than or equal to 10.
Yeah, so 7 fits between 5 and 10. So it's right in this second domain. And what's our function?
5.
5. Doesn't matter what x is, our function's 5.
Just 5.
So for no matter what our x value is between 5 and 10, our entire function is just going to be 5. That's that horizontal line. Okay? The next one, f of x equals 3.
It's just 3.
So f of x equals 3, that now is my y value, right? That equals 3. So I look on the y-axis, it's just going to be at 3, 3. Good. Now if I'm looking at f of x equals, now I would have to be more concerned with the range because I'm actually trying to figure out where the ranges are. And we've only set up the domains. So the best option for us here is to see, okay, where is x equal to, where is y equal to 3 on the actual function? It's easier and better to analyze the graph here. How about the next one? So you would also write x equals 3 there. What about where f of x is equal to 13? Now am I looking on the x-axis or the y-axis though for where?
1.
Yeah, because I'm saying f of x is equal to 13. So when I look at that, I see right up here, this is 13. So where's the function? Yeah, it's at 14, 13, right?
Double X.
I'm sorry, my iPad was freaking out. Okay. But is there anywhere else that this function is equal to 13? It's equal to it right there, but isn't it also equal to it over there?
Yeah.
Yeah, it's also equal to it. What's that value?
Wouldn't that be
13.
Almost.
17. Yeah.
The cloth. 17, yeah.
Numbers are difficult.
Ugh.
Hey, at least you don't drink yours with radiation level. Miss Gomez heats it up like 20 times
Oh.
a day.
Yeah, I let mine cool so I can chug it. What about F of 15?
15.
Oh yeah, look up there. It's at 15, 15. Now, if I were coming down here though, how can I tell which function to use? Is 15 between 0 and 5?
No.
Is it between 5 and 10? Is it between 10 and 15?
Yes.
Oh, yeah.
Yes, because of this equal sign, right? So then I can plug it into that equation again. I've got 15 times 2, which is 30 minus 15. That's 15. Beautiful.
When it's too much to write, so you just write third
Hmm?
function. I've been writing second function, third function, like so that.
Oh, nice.
Mike
Good
loves
thinking.
hers.
It's like when it's too much to write, so you just write function number.
Ethan.
All right. So that is where we will stop for right now. I want you guys to take about 20 minutes and work on the homework. Okay? And then we're going to hippity hop right into bike lovers. It is like Ethan. All right. Pitter patter.